Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 6 from the January 2022 Statistics S1 International A-Level Edexcel paper. This question is about regression and correlation. It says students on a psychology course were given a pre-test at the start of the course and a final exam at the end of the course. The teacher recorded the number of marks achieved on the pre-test P, on the x-axis, and the number of marks achieved on the final exam F, which are on the y-axis, for 34 students, and displayed them on a scatter diagram. Okay, now it says the equation of the least squares regression line for these data, which means the equation of the line of best fit, is found to be F final score equals 10.8 plus 0.748 times P, which is the pre-test score. For these students, the mean number of marks on the pretest is 62.4. Use the regression model to find the mean number of marks on the final exam. Okay, so basically, this is telling us find F when P equals 62.4. So P equals 62.4. So therefore, F will be 10.8 plus 0.748 times 62.4. So you have 10.8 plus you have 0.748 times 62.4. Be careful not to make a mistake with your typing. Alright, good. That gives me 57.4752. So F equals 57.4752. So therefore we can say F is equal to 57.523 as F. There's the answer. That's the mean score, mean number of marks for the final exam. Okay, then it says, B says, give an interpretation of the gradient of the regression line. So the gradient of the regression line, so the gradient is equal to 0.748, and here the regression line is F against P. So basically it's the change in F, the rise over the run. So the change in F divided by the change in P. So what it means is basically if the pre-test score increases by 1, we can say for every 1 mark increase, it's a better way of writing it, for every increase of 1 mark in the pre-test, the final exam score increases by that value, which is a gradient, increases by 0.748. That's what it basically means. The gradient of a graph is the change in y over the change in x. So for every 1 increase in the pre-score, the final exam score will increase by 0.748. That's how we can give an interpretation of the gradient of regression line. That's part B. Now for part C. It says, considering the equation of the regression line, Priya says that she would expect someone who scored 0 marks on the pre-test to score 10.8 marks on the final exam. Basically, when P equals 0, F equals 10.8. However, is that reliable? Well, no. The reason being is because our data doesn't include any points which have 0 marks on the pre-test. All right? So we can say that our data values do not include values of 0 for the pretest. Therefore, this is unreliable. It's unreliable to predict. Okay, it's unreliable as we are what's called extrapolating. Okay, you should always predict within the range of the datas, okay, that we have, the data values we have. Don't ever predict something which is out of the range of the data values we have. Alright, so as our data values start from, like, for the pre-test, start from like 20, we can predict from that, you know, like 19 or whatever, 20. We can predict from that up to, you know, the highest marks. We can't predict anything lower than that, okay, because it is called extrapolation. We don't have data for that values. So that's what they're asking us to do there. That's question 6, part C. Now for part D, it says write down the number of marks achieved on the final exam for the student who exceeded the expectation of the regression model by the largest number of marks. So if we go back to this diagram here, now basically he exceeded the expectation. So that means that the difference between the final score minus P is going to be the maximum amount. Okay, the final score minus the pretest has to be the biggest difference. So obviously we're looking for values which are low on the pretest but higher on the final exam. So I can see that there's this one here. That looks like one that might be what we look. So we can see here that this is 70, that's 246. So that one's going to be 76 minus 60, which is 16. Can we see any that give us a bigger difference? How about this one here? That's going to be, that's like 65 minus, and this is 40, that's 52. That's 13, no, so far it's this one. It looks like it's going to be this one, actually. I don't think any of the others will have a big difference in that. So it says write down the number of marks achieved on the final exam. So that final exam, that's 76. So you just put 76 here. It's 1 mark, that's fine. Okay, so we identified that the point that had the biggest difference between the pretest and the final exam being higher than the pretest. Okay, so that's part C, and now for part D. Oops, part D is where? No, actually that was part D. Now for part E, it says find the range of values of P for which this regression model f equals 10.8 plus 0.748p predicts a greater number of marks on the final exam than on the pretest. Okay, so we're going to find the range of values of P for which the marks on the final exam are greater than that on the pretest. So they'll be equal to each other, okay, along this line. Let me make the line a bit thinner. This line is where the pretest and the final mark will give you the same value. Okay, so this will be where they're the same. Okay, that's where you can say is the line f equals p. Okay, and this is our regression line. So we can see that we want to find where the you have a greater number of marks on the final exam than on the pretest. That's where they're equal to each other. Okay, along this line. So above this line is where you're going to have the greater number on the final exam as compared to the pretests. Like, for example, if I shaded this area over here, okay, I shaded this area over here, then it'll be the region from here and below, okay, this unshaded region, okay, from this section from here and below, that the marks on the pretests are going to be higher on the final exam, are going to be higher on the pretest than on the pretest. Okay, so this point where they intersect here and what's below that. So when p is equal to this value over here. So I'm going to do this by in an algebraic way, because this is not very reliable to read these marks. It's not that accurate. So what I'll do is I'll say, okay, at that point where f equals p intersects this line. So where does the line f equals p intersect with f equals 10.8 plus 0.748748p? Where do they intersect? Well, they intersect okay, if you solve these two simultaneously. So I can replace this with P, because we want to find the values of P. So P is equal to 10.8 plus 0.7, 0.748 P. So if I do P minus 0.748 P equals 10.8. So I'm going to subtract these. So I'll have P minus, so I have 1 minus 0.748. That gives us 63 over 250, which is 0.252. 0.252 P equals 10.8. So P is equal to 10.8 divided by 0.252. So I'll do 10.8 divided by the answer, which gives me 42.857. 42.857. So that we can say that when P is less than, so when P is less than 42.8 or 42.9, we could say 3SF. When P is less than 42.9, that's when the final mark will be greater than the the pretest. Okay, when F is greater than P. Okay, in that region here where F is greater than P, that's where F is equal to P, and in this region here above that is where F is greater than P. So that's what we're trying to find here. So that's the answer to that part of the question, which is part E, sorry. Now we're going to go on to part F. Now part F says, later the teacher discovers an error in the recorded data. The student who achieved a score of 98 on the pretest scored 92 and not 29 on the final exam. So there's like a entering mistake. The summary statistics used for the model F equals 10.8 plus 0.748p are corrected to include this information, and a new least squares regression line is found. Now, given that the original summary statistics were this is including the mistake, okay, calculate the gradient of the new regression line, showing you're working clearly. Okay, so now, what we got to do is the gradient of the regression line. So if we go to our formula book, okay, I've got them saved over here. I've just copied these from the formula book. Now, from the formula book, these two equations are what we need. The regression line, or the regression coefficient of y and x is b equals. So this is basically the gradient of the regression line b. Okay, sx over sxy over sxx. That's basically the same as saying spf over s. Now remember, it was final and p. That's going to be spp. So that's going to be what our b is equal to. So we have to find the new values of spf and the new value of spp. Now the mistake was in the final exam, okay, on the final exam. So the student who chooses 98 on the pretest scored 92 and not 29 in the final. So the mistake was in the final exam. So SPP is going to be the same. SPP, the new SPP is the same as the old one, 15,573.76. That's not changed. So that's fine. Okay, but SPF, okay, is going to change. All right, SPF is going to change because SPF, all right, is going to be, of course, SPF is going to be given by this. We can see SPF is going to be basically the sum of, you can say P times F minus the sum of P times the sum of F over N. Now, the sum of P is the same. Okay, so the sum of P will be the same. So the sum of P will still be 2,120. That's the same. Okay, that's the same. But the sum of F will change because we have the final score has there was this mistake. So the sum of the final scores is going to be changed. So that tells us the sum of the final scores. So we got to work out the new sum of f, and we've also got to work out the new sum of p times f. Okay, and then we can get our answer. So we need the new sum of pf, and we also need the new sum of f. Okay, so let's look at the sum of f first. All right, now for the sum of f, okay, we can use the fact that we know that the old SPF is this. So we can say SPF is equal to 11,648. So SPF is equal to 11,648.35. Okay, and we can say SPF is given by the sum of PF. So the old sum of PF is 133,486. So we can say 133,486. That's the old sum of PF. Okay, minus the sum of P, which we have 2,120 times the sum of F. Now that's what we don't know. The old sum of F we don't know. Okay, it's not been given to us, so I'm trying to find that first. Okay, divided by the number, which is 34. And we know that the old sum of PF is going to be basically this number here, which is 11,648.35. Now with this I can find the old F, sum of F. Okay, so I can rearrange this. This is going to be 2,120 times the sum of F over 34 equals 133,486 minus 11,648.35. So I can now work out what the sum of F is. It's going to be basically 34 times this over 2,120, 34 times this, which is 133,486 minus 11,648.35. Okay, so that's 121,837.65, 121,837.65. The 34 divided by 2,120, just rearranging this equation. So we can say, therefore, the sum of F is going to be equal to this times 34 divided by 2,120, which gives us 1,954. 1,954.00. Leave it like that. That's fine. So that's the old sum of F. So we need the new sum of F. So basically, the new sum of F, we could call it F dash, sum of F dash, is going to be the old sum. Now, what was the mistake? The mistake was they wrote 29 instead of 92. So if we take away 29 and add 92, you're taking away the error and adding the actual value, and that will be the new sum of F. So I'll call it F dash, the sum of F dash. So I'll take the old value, I will take away 29, and then I'll add 92, and that gives us the new sum of F, which is 2017. So that's the new sum of F. So we've got now this. We got to find, we know that this is also the same as before. Now what we got to find is the new sum of P times F. Now we have the old sum of P times F. Okay, so we got the sum of P times F is 1,300, 133,486. Okay, that's the old. Okay, so we can say that the new sum of PF is going to be the old product. So it's not the sum of the product of P and F is 133,486. And now I'm going to take away the old product. Okay, so the old product is going to be P would be the same, okay, which was 98, and F would be 29. So that's 98 times 29. That will take away the mistake. So this is the sum of the products of P and F. So that was a wrong product. Then I'm going to add the correct product, which is 98 times 92. That's the correct product for that one entry that was wrong. So that will give us the new value for P times F. So if I take this 133,486 and I subtract from it 98 times 29, then add to it 98 times 92. So I've taken away the wrong product and I'm added the correct product. That gives me 139,660. So that's the correct value now of the product of P and F. So now I can use this formula here. You've got the sum of PF, which is what I have now. The new value of SPF. So SPF dash is going to be the sum of PF, which is 139,660 minus the sum of P times the sum of F. Now the sum of P has not changed. It's 2,120. So 2,120 times the sum of F, which now is the new sum, which is 2,017 over 34, which is the number of entries. So that's going to give me the new values of SPF. So I'll do that. This minus, I'll have 2,120 times 2017 divided by the number of entries, which is 34, and that gives me 13,894.12. 13,894.12. Okay, that is the new SPF. So therefore we can say B, our regression line coefficient, is SPF over SPP. SPP is the same, okay, which is this value here. So we're going to have SPF, the new value, which is 13,894.12 divided by SPP, which is 15,573.76. 15,573.76. Let's just move this out of the way. And that will give us our new gradient. Okay, so we've got this value divided by 15,573.76. Okay, and that gives us 0.892. 0.892. That is a new gradient. Okay, and that concludes this question. So that last one is a bit involved here, but I hope that was clear. So because we need to find the value of B, we need to have SXY, which is SPF basically, or SPF over S, and this is SX is P, SPP. So the pre-score is correct, so SPP was fine. Is this what we have to find? We have to find SPF. To find SPF, we have to use this formula, right? And in this formula, this has changed, and this has changed. So we had to find the new values of these two. Okay, some of the pre-scores were still the same. So we found the values of these two. For this, it's not a problem. It's just that one entry that was wrong. So it's going to be 98 times 29. Take that away. That takes out the wrong product. And then you add 98 times 92. That gives us the correct sum of the products. But the sum of F, they didn't tell us. So we had to work out the sum of F using the old value of SPF. Okay, because SPF is going to be the sum of PF, which we have the old one, minus the sum of P times the sum of F over 34, and that way we can find what the sum of F is. Okay, so that's how we dealt with that question. So that concludes this question, and that concludes all the questions on this paper. Other questions from this particular paper you can find by clicking on the link over here. Other questions from this topic of regression and correlation you can find by clicking on the link over here. You can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.